Good morning, students. So last class we discussed some of the problems on the properties of determinants. So in this today class now we can complete that remaining problems. Okay. In the next one is determinant of a plus b plus c, 2a, 3a plus 2b, 4a plus 3b plus 2c, 3a, 6a plus 3b, 10a plus 6b plus 3c will be equals to a cube. So for the properties, so what we are doing is, so take on the LHS and prove the RHS, right? So let us take on the LHS. LHS equals to determinant of a plus b plus c, 2a, 3a plus 2b, 4a plus 3b plus 2c, 3a, 6a plus 3b, 10a plus 6b plus 3c. So you want only the a term, right? So for that, so in any row or any line, eliminate that. See, if you eliminate this minus this, so from this row you can subtract this row. So R2 can be changes to, so this 2a is in R2 minus, if you subtract this means, so this is 2a plus this is you get just a. If you cancel that element to make it as 0 means, you can multiply that element of R1 with 2. So R2 is 2a, minus 2 times of R1 is 2 into a is 2a. So 2a minus 2 you got 0. So same like for this row and this row. So this is in which row? It is in third row. So means R3 changes to R3. So for this you can multiply 3 means it becomes 3a. So 3a minus 3a becomes 0, right? So R3 minus for R1 you are multiplying with 3. So R3 changes to R3 minus 3 times of R1. So now we can apply those elementary operations. So R2 and R3 will change, R1 will be as it is. So what is that R1? It is A and A plus B, next A plus B plus C. So this is R1. What about R2? R2 can be changes, R2 minus 2 times of R1, right? What is that R2? R2 is 2A minus 2 times of R1 is 2 times of A. 2A minus 2 you got 0. Next, so for these two elements, R2 is 3a plus 2b minus 2 times of R1 is minus 2 into multiply these two, minus 2 into a, minus 2a, minus 2 into b is minus 2b. So plus 2b minus 2b gets cancelled, 3a minus 2a, you got the a. So next, again same these two elements, R2, it is as it is, so 4a plus 3b plus 2c minus 2 times of R1. For all these elements you can multiply with minus 2. Minus 2 into a, minus 2a, minus 2 into b, minus 2b, minus 2 into c, it's minus 2c. So plus 2c minus 2c gets cancelled. 4a minus 2a is 2a, 3b minus 2b is just plus b. So it is R2. Now R3 can be changed, R3 minus 3 times of R1. R3 here is 3a, minus 3 times of R1 is minus 3a minus 3. So 3a minus 3 you got 0. Same like these statements. R3 is 6a plus 3b. So minus 3 times of R1 is multiply with minus 3. So minus 3a minus 3b. Plus 3b minus 3b gets cancelled. 6a minus 3a you got 3a. Next, same these two. So R3 is 10a plus 6b plus 3c. For this R1 multiply with minus 3. You will get minus 3a minus 3b minus 3c. Plus 3c minus 3c gets cancelled. 10a minus 3a is 7a. 6b minus 3b is it's plus 3. So this is about R2 and R3. So once again I will apply these two. So this minus 3 times of this. So this is R3. Minus 3 times of this one means 3 times of R2. So obviously which will change? R3 will change. Remaining R1 and R2 will be as it is. Okay. So now see the remaining elements. What about R1? R1 is as it is. A plus B, A plus B plus C. R2 0, A 2a plus b, R3 R3 minus 3 times of R2. So means these two, these two, these two. 0 minus 3 times of 0 is obviously 0. 3a minus 3 times of a is minus 3a. So 3a minus 3a you got 0. Next 7a plus 3b. So this is R3 minus 3 times of R2. For this multiply with minus 3. Minus 3 into 2. Minus 6a minus 3 into b is minus 3b. So plus 3b minus 3b gets cancelled. 7a minus 6a is it's just a. Okay. Now see below the principal diagonal elements. All are zeros, right? So multiply the principal diagonal elements. So that equals to a into a, that equals to a cube. That should be the RHS. Got it? Next one. Determinant of 3a minus a plus b minus a plus c minus b plus a 3b minus b plus minus c plus a minus c plus b 3c equals to 3 times of a plus b plus c into ab plus bc plus c. Okay, see the LHS. So this is LHS, and to make it LHS, a plus b plus c or ab plus bc plus c. For this a plus b plus c, see, I will add this 3a minus a 2a plus b. Again 2a minus a already plus b plus c. You got this one right? So if you add this plus this means columns. So you can apply the elementary operation as a column. First write the LHS. So 3a minus a plus b minus a plus c minus b plus a 3b minus b plus c minus c plus a minus c plus b and 3c. Okay, so you are applying elementary operation as column 1 changes to column 1 plus column 2 plus column 3. So this column plus this column plus this column. So add the corresponding columns you will get. So 3a minus a 2a minus a with plus b plus c. You will get a plus b plus c. So now these three. So minus b plus 3b minus b 2b minus b is plus b plus c plus a. You will get a plus b plus c. Next same minus c minus 2c. Minus 2c plus 3c, c plus a plus b. So that can be rearranged as a plus b plus c. Okay, column to column 3 as it is. Minus a plus b, 3b, minus c plus b, minus a plus c, minus b plus c, and 3c. Now, taking common factor, a plus b plus c from column 1. From the column 1, enter a plus b plus c will be the common. So a plus b plus c will be taken as a common from the column 1. What is remaining in column 1? 1, 1, 1. Column to column 3 as it is. Minus a plus b, 3b, minus c plus b, minus a plus c, minus b plus c, and 3c. So now for this, if you apply column 1, you can apply row 2, right? R2 changes to R2 minus R1, come on. R3 also changes to R3 minus R1. Okay, so let's see whether what is the answer it will get. So that equals to A plus B plus C. So what about R1? It is as it is 1 minus A plus B minus A plus C. So R2 can be taken as R2 minus R1, right? So this minus this, 1 minus 1, 0. Now this minus this, 3b minus of this one, that is minus A plus B. So 3b minus into minus plus A minus B. 3b minus B, 2b plus A is A plus 2b or 2b plus A, both are same. Next, so this minus this, so minus B plus C, with minus of minus is minus A plus C. So what it becomes? Minus A. So it's minus A and minus A. For this minus of, will get that minus of minus plus A and becomes minus A. Minus of minus A plus A, right? Minus of minus A becomes plus A, minus into plus becomes minus A. So again, plus C minus A gets cancelled. What is remaining? So minus B plus A or A minus B, both are same. This is R2 minus R1. Similarly, R3 changes to R3 minus R1. So this minus this, 1 minus 1, 0. This minus this, minus C plus B, then minus of minus A plus B. So minus C plus B, minus into minus plus A, minus into plus minus B. Plus B minus B gets cancelled, remaining A minus C. Next, this minus this. So 3C minus of minus A plus C. So 3C minus into minus plus A, minus into plus minus C. So A, 3C minus is 2C, right? You will get A plus 2C. So this is what you got for the, which one? R2 changes to R2 minus R1 and R3 changes to R3 minus R1. So now normal you can expand. Plus minus plus. So that equals to A plus B plus C. For the one, multiply these two. A plus 2B into A plus 2C minus multiply these two. A minus B into A minus C for the 1. Next, minus of minus. So that is minus of, so it is minus only for the minus A, right? So minus of minus A plus B. For this first row, second column you can do 0 into A plus 2C, 0. Minus A minus B to 0, that is also 0. Next, again plus of this one. So plus of minus A plus C. For this you can do the first row, third column. 0 into A minus is 0. Minus again 0 into A plus 2B, that is also becomes 0. So entire this term becomes 0, right? So you get only this term here. So that equals to, so A plus B plus C. If you multiply one with means, you get both are the same only. So A into A square, A into 2C, 2AC, 2B into A, 2AB, 2B into 2C, 4 times of BC. Next, minus A into A, minus A square, minus A into minus C. So minus into minus becomes plus AC. Minus into minus plus B into A, AB. Minus into minus plus, again plus into minus B into C is BC. So this is remaining term. Plus A square minus A square gets cancelled. 2AB plus AB, 3AB. That equals to A plus B plus C into 3AB. Next, 4BC minus BC. 3 times of BC. 2AC plus AC. So 3 times of AC. So all the 3 terms will get 3 as a common, right? If you take that 3 as a common, what is remaining? 3 times of A plus B plus C into AB plus BC plus CA or AC, both are same. So that should be the RHS. So this is how you can prove the determinants by using properties. Okay? Next one. 16. Determinant of a square bc ac plus c square, a square plus ab b square ac, ab b square plus bc c square will be equals to 4 times of a square b square c square. So this is you have to prove. Okay, same. Let's by using the properties of determinants, you can prove that one. Okay. So the next question, same. Taken the LHS. LHS equals to determinant of a square bc ac plus c square, a square plus ab b square ac, ab b square plus bc c square. Okay. So now you want 4 times of a square b square c square, right? You cannot add and you cannot any subtract. If you add and subtract means you will get in terms of addition or subtraction. But we want in terms of multiples, right? So most of all you can take in terms of the common. Okay, first see in the first column a. In these two a as a common, b in these two b as a common, b c. So obviously get the common, right? Taking common factor a from column 1, b from column 2, c from column 3. So this can be taken as a common. So what is that common? A, B, C from the column 1, column 2 and column 3. From the column 1 A is a common, right? In this column 1 leave A, in that A square, A will get remaining A. In these two A is common, remaining A plus B. In this remaining B. So in the column 2, B will be the common, right? The remaining C, B here becomes B plus C. Now column 3, C will be the common, right? Remaining A plus C, A, C. So this is the remaining terms after taking A from column 1, B from column 2, C from column 3. So now afterwards, so what we can do? So we can make any operation to make it as a 0. Why to make it as 0 means to expanding the problem it should be very easy. So for that what I am doing means, so this one, for this A plus B, I can add these two, A plus B. A plus B minus A plus B becomes 0, right? So this is in R2. For this, I am adding these two, which two? R1 and R3. Afterwards, subtracting this element with this element, right? So R2 can be changed as R2 minus of R1 plus R3. Okay. So what is the answer it will get? So A, B, C. What is the first row? It is as it is. A, C, A plus C. What is the second row? R2 minus of R1 plus R3. What is the R2? A plus B. Minus R1 is A plus R3 is B. A plus B minus of A plus B got 0, right? Next, for this is computed. For this, R2 is B minus of R1 is C plus R3 is B plus C. So B minus into B minus B gets cancelled, right? So C plus C 2C with minus you will get minus 2C. Next, same in this also. R2 is A minus of R1 is A plus C plus R3 is plus C. Same A minus into A minus A gets cancelled. C plus C 2C with minus we got minus 2C. Now what is remaining? B, R3, B plus C and C. So this is remaining in the R3. So to make it as a one more 0, what we can do now? So we can do here. If you subtract this minus this, we will get one more 0, right? So make that as C2 can be changed as C2 minus C3. Okay. Apply the elementary operation as C2 changes to C2 minus C3. What is the ABC? ABC into column 1 A0B as it is. What is column 2? Column 2 can be changed as column 2 minus column 3. Column 2 is C minus of column 3 is a plus c. C minus into c, minus c gets cancelled. Minus into a you got minus c. Next, minus 2c minus column 3 is minus 2c. That minus becomes plus right. Again minus 2c plus 2c gets cancelled. 0. Next, again column 2 b plus c minus column 3 c. So plus c minus c gets cancelled. You get b. What about column 3? It is as it is. So a plus c and minus 2c. Next c. So this is column 2 changes to column 2 minus column 3. So you got in the R2 you got 2 zeros right. So then you can expand. It becomes very simple. Plus minus plus. So a b c. For the first element a, you can use the first row, first column. 0 into c, 0 minus b into minus 2c, minus 2bc. So that minus into minus becomes plus, right? It becomes 2bc. Okay, next. Minus into minus, plus c. For this element, you can do the first row, second column. 0 into c, 0 minus b into minus 2c, minus 2bc. So that minus into minus becomes plus, right? It's 2bc. Next, for last element, plus of a plus c. For this element, you can do the first row, third column. 0 into b is 0, minus again 0 into b is again 0. What it does? So now, so this entire term becomes 0. So what is remaining? A, B, C. A into 0, 0. A into 2bc, 2 times of ABC. A into 0, 0. A into 2bc, 2 times of ABC. So that equals to ABC. 2ABC plus 2ABC, how many times? It is 4 times of ABC. If you multiply that one means 4 times of ABC to ABC is A square, B square, C square. So that should be the RHS. Got it? We'll move to the next one. So next, 17th one. Determinant of alpha square beta plus gamma, beta square gamma plus alpha, gamma square alpha plus beta will be equals to alpha minus beta, beta minus gamma, gamma minus alpha into alpha plus beta plus gamma. So this is what we have to prove. So according to the previous properties, what we did. So for alpha minus beta, for this minus this subtraction. For beta minus gamma, this minus this subtraction. For gamma minus alpha also you can substitute, but you can apply. But for the 3 cross determinant, how many operations you can use? We can use the maximum 2 elementary operations. We cannot use the 3 elementary operations. Okay. So now, for the alpha minus beta, you can subtract R1 minus R2. For beta minus gamma, we can subtract R2 minus R2. Okay. So let us apply those elementary operations. So we can see for the next one. Okay. So alpha square beta plus gamma, beta square gamma plus alpha, gamma square alpha plus beta. Okay. So now for these two, you are applying R1 minus R2. For that R1 will change. For beta minus gamma, so this minus this. So that is R2 minus R3. So you can change the R3. Okay. So now what you will get for the R1 minus R2? So for this row and this row, what you can subtract alpha minus beta, alpha square minus beta square. So next, beta plus gamma minus of these two, right? So for those two, minus will apply. Minus gamma minus alpha. Gamma minus gamma gets cancelled. What's remaining? So beta minus alpha. Okay. Now R2 changes to R2 minus R3. So these two rows. So this row and this row, right? So this minus this. Beta minus gamma. So this minus this. Beta square minus gamma square. Same this minus this. So gamma plus alpha. For this you can apply minus, means minus apply to both the elements. Minus alpha minus beta, both are gets cancelled. Alpha minus alpha, remaining gamma minus beta. Okay. Now next gamma square alpha plus beta. So got this one. Now in the R1, so in this alpha minus beta, you can write this also alpha plus beta into alpha minus beta. There also you get alpha minus beta. But here beta minus alpha is there, right? To get as a alpha minus beta, just take minus as the common. So same procedure applied for the row 2. Okay. So first write that one. So what is that one? Determinant of alpha minus beta. So these two can be written as alpha plus beta into alpha minus beta. So in these two, which is common? Minus is common. What is remaining? Alpha minus beta. For the R2, so this is beta minus gamma. So next this can be written as beta plus gamma into beta minus gamma. So in these two, minus will be the common, remaining beta minus gamma. Next R3 as it is gamma square alpha plus beta. Okay. So now taking common factor, which one? Alpha minus beta from R1, come on, beta minus gamma from R2. From the R1 and R2, you can take that alpha minus beta and beta minus gamma as a common factor. So that it can be taken as alpha minus beta, beta minus gamma can be taken as a common from R1 and R2. From that R1, leave alpha minus beta. So 1. Next, alpha plus beta minus 1. If you leave that, alpha minus beta is a common from R1. R2 beta minus gamma you can leave. 1. Beta plus gamma minus 1. So R3 as it is. So gamma square alpha plus beta. Okay. So now you got alpha minus beta, beta minus gamma. Now you want gamma minus alpha, right? So this is gamma, so this is alpha. You can subtract this minus this. So what about these two? If you subtract this minus this, beta minus beta gets cancelled, right? So apply R2 can be changed as R2 minus R1. So you can subtract this minus this. So R2 minus R1. So what you get? Alpha minus beta, beta minus gamma, R1, 1 alpha plus beta minus 1. R2 can be taken as R2 minus R1, right? 1 minus 1, 0. So this minus this, right? So beta plus gamma, for these two apply with minus. So it is minus alpha minus beta. Beta minus beta gets cancelled, remaining gamma minus alpha. So minus 1, minus of minus becomes plus 1. So again minus 1 plus 1 gets cancelled, you get 0. Okay, next gamma square alpha plus beta. So same thing, taking common factor, which one? Gamma minus alpha from R2. Okay. So now alpha minus beta, beta minus gamma. So gamma minus alpha from the R2. What is R1? 1 alpha plus beta minus 1. So it is 0. Gamma minus alpha can be taken as outside, remaining 1. So it is also 0. So R3 as it is. So gamma square alpha plus beta. Okay. So now this is also you got, and you want only one term alpha plus beta plus gamma. For that, so just expand. So that's it. So that equals to alpha minus beta, beta minus gamma gamma minus alpha. So this is for first one. 1 into alpha plus beta is alpha plus beta minus 0 into gamma square is 0. Okay, next minus of alpha plus beta for this first row, second column we can do 0 into alpha plus beta 0 minus 0 into gamma also will get 0. Next third plus into minus 1 for this first row, third column we can do 0 into gamma square 0 minus 1 into gamma is gamma. Okay, so now write a remaining term. So that equals to alpha minus beta, beta minus gamma, gamma minus alpha. 1 into alpha plus beta, that's all. 1 into 0, 0. So alpha plus beta minus alpha plus 0 minus 0 is total 0. Minus 1 into minus plus, so this is gamma. So that is alpha plus beta plus gamma. So that can be the RHS. So this is how you can prove by properties of determinants. Okay. So we will discuss the last one in the properties of determinants. So these are very important for the 4 mark questions. Okay. So but main thing what you can know is how we can solve this by properties of determinants. So determinant of x square 1 plus p times of x cube, y square 1 plus p times of y cube, z square 1 plus p times of z cube will be equal to 1 plus p xyz into x minus y into y minus z into z minus x, comma, where p is any scalar. So what is meant by scalar? It is just a value. Okay, so like a non-zero number. So for this, how we can prove the problem? Okay, same what we did in the previous. For this 1 plus p x y z, so they should not say any common like that. For x minus y, this minus this. For y minus z, so this minus this. So instead of that one, so I will apply first here property number 5. You know the property number 5, right? Property number 5 is splitting of determinants. When the determinant can be split, a row or a column can be expressed as 2 or more terms, then the determinant can be split into 2 or more determinants. This is property number 5. Okay, so now in the determinant, so column 3 can be expressed as 2 terms, right? Column 1 x y z, column 2 x square y square z square, column 3 1 plus px cube, 1 plus py cube, 1 plus pz cube. So column 3 can be expressed as 2 terms, right? So that is determinant, it can be split into 2 determinants. So for the first determinant, column 1 x y z, column 2 x square y square z square, column 3 can be written as only first element, that is 1 1 1, plus now second determinant, column 1 will be as it is x y z, column 2 is x square y square z square, and column 3. Now from the first column 1 x remaining 1x x square, y 1y y square, z 1z z square, so 1z z square. Okay, now see, so these two are also obviously multiple equal only. So when it will be equal means, so this can be shifted to here, column 3 can be shifted as column 1, after column 1 can be shifted as column 2. So obviously you get both will be equal. So what all you can apply here? You can apply. Okay. Now for the x minus y, what we can do? X minus y is r1 minus r2. Next for y minus z, r2 minus r3. For this which rows will change? So here R1 will change, here R2 will change. Okay, right, that's it. 1 plus P times of x, y, z. R1 minus R2. 1 minus 1, 0. Here is a x minus y. X square minus y square. I can directly apply the formula x minus y into x plus y. Next R2 minus R3. This row minus this row. 1 minus 1, 0. Y minus z. Next y square minus z square, applying the formula y minus z into y plus z. What is the last row? 1 z square as it is. Now in this step what you can do? Taking common factor which and all? X minus y minus z. So x minus, okay, write that separately. So taking common factor x minus y from R1, y minus z from R2. So 1 plus P times of x, y, z, which is common. X minus y under y minus z, right? What is remaining in the first row? 0. X minus y common. 1. X minus y common. Remaining x plus y. 0. Y minus z as a common. Y minus z as a common, remaining y plus z. And the last one is 1 z square. Okay. So now you got x1 plus px by z, x minus y minus z. You want only z minus x, right? For that you can just simple the expansion. So that equals to 1 plus p times of x y z into x minus y into y minus z. So normal plus minus plus, right? First 0, you can multiply anything 0. Next for minus 1. For this we can leave first row, second column. 0 into z square is 0. Minus 1 into y plus z. You can multiply with minus, means it becomes minus y minus z. Or we can just write that as no problem. So minus of y plus z. Okay. Next for next one. So I can write it here. So that equals to 1 plus p times of x, y, z into x minus y into y minus z, right? So if you multiply means for first 0 of anything 0. Next minus 1. For this minus 1, you can leave first row, second column. 0 into z square is 0 minus 1 into y plus z is y plus z. You can put a bracket for that one, y plus z. Next plus of x plus y into, you can leave the first row, third column. 0 into z is 0 minus 1 into 1 is 1. So now simplify 0 into 0. So minus 1 is 0, that is a 0. This minus into minus becomes plus. So this one is 0, this becomes minus. So that equals to 1 plus p times of x, y, z into x minus y into y minus z into minus into minus becomes plus. 1 into y plus z is y plus z. X plus minus 0 is 0. Minus 1 into x, minus 1 into y is minus 1. So plus y and minus y gets cancelled. What is remaining? 1 plus p times of x, y, z into x minus y into y minus z into, so z minus x. So that should be the RHS. So this is the given problem and the given proof. Got it? So this is how we can solve the properties of determinants. This is very important for the 4-mark questions. Okay. So next concept is about area of triangle. So you know about area of triangle? So in the 9th standard you studied the area of triangle is like half into base into height, or by using the Heron's formula, root of s into s minus a into s minus b into s minus c. And in the 10th standard you studied about 3 points: x1 y1, x2 y2, x3 y3. So then what is area of triangle? Area of triangle is 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Now in the second quiz, we can same solve the area of the triangle by using the concept of the determinants. Okay. So area of triangle. So you know the area of triangle delta equals to half into base into height. in the 9th standard. In the 10th standard, area of triangle equals to 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is a formula you are discussing in the 10th standard, right? Now in the second PUC, you are doing the area of the triangle. So by which method? We can do by determinant method. So what is by determinant method means? So let us take up that 3 points, 3 vertices, A of x1 y1, B of x2 y2, C of x3 y3. So by using the determinants to find area of triangle means, so delta equals to 1 by 2 times of determinant of x1 y1 1. So this is half as it is, right? Next x2 y2 1, x3 y3 1. You can write this, or so equals to 1 by 2 determinant of x1 y1 1, x2 y2 1, x3 y3 1. So this is by using the concept of interchange of rows and columns, right? If all the rows and all the columns are interchanged, so the value of the determinant remains same, right? So see, if you expand this one, same will get the same like this only. 1 by 2 plus minus plus. For x1, you can be first row, first column. y2 minus y3. Next plus x2 here minus becomes, for x2, y1 minus y3 will get. But here you get y3 minus y1, right? If you take that minus as a common, that minus becomes plus, so x2 into y2 minus y3. For plus x3, y1 minus y2. So this is by using the concept of determinant, how you can find the area of a triangle by using determinants. So this is very important for the 2 marks questions. Okay. So now in this, so there are the 3 concepts. So what are the 3 concepts means? So area of triangle is always a positive quantity, right? Since area is a square units and volume is a cubic units, since area of a triangle is always a positive quantity, suppose if you solve any triangle, you get delta is equal to 12 square units. What is the area of your area? Also you can raise 12 square units. Suppose while you solving the problem, you will get minus 12, but obviously you can write that answer as a plus 12 square units only. Since area is a positive quantity, if it is negative or if it is positive, but obviously you can write as a compulsory positive only, or this can be write as 1 by 2 mod. You know mod, right? So mod means taking that negative as also the positive as. So this is the first concept. So since area should be a positive, while solving the answer you get negative also, you can write that as a positive quantity. So this is the first concept. Now moving to the second concept. In the second concept, suppose to find sum of the point here. Suppose a of x1 y1, b of x2 y2, some c point can be taken as a some k comma 0. Okay. So while applying the formula, so write the delta equals to 1 by 2 modulus of x1 y1, x2 y2 1, x3 y3 1. So they will give that area as some 3. Okay, delta is equal to 3 square units. So this 3k is the right is should be any number, whether it is a positive number, whether it should be a negative number, but cannot be 0. Okay, for this k, whether you have the 2 values, you will get the same answer. Suppose if you took one of the values 3, suppose if k is 3, answer also will get some plus 3 square units on. Suppose you take some k is equals to minus 8. For this also, you will get answer as minus 3 square units. But since area is a positive quantity, you can write this minus 3 can be as plus 3 later. So whether it should be minus 3 or plus 3, the area can be taken as positive only. For 2 values, you will get that. So 2 areas, whether it should be positive or whether it should be negative, but you can consider both areas only, right? So for any 2 values, you will get right. So for that, area can also be taken as a 2 values, whether it should be positive or negative. For 2 values, you will get 2 different areas, but areas is same, but you will get whether positive or negative. So that's why. So based on the k value, you can take in both the squares. and positive as well as the negative also, because for one value you apply, you get the plus 3 square roots. For another value if you apply, you will get minus 3 square roots. Again that minus 3 also is 3 square roots only, right? That's why you can consider both plus or minus if area is given, and to find any unknown value we can use that area can be plus or minus. Okay, so this is the second concept. And the third concept. So what is the third concept means? Suppose to find equation of those lines of a triangle. So they have given that A some x1 y1, B some x2 y2, C some x3 y3. So these are lying on the same line. If all the 3 points which lie on the same line, then what about its area? So delta, that is area of triangle, is obviously 0, because there is no triangle formed. If there is no triangle formed, you will get any area, so no, right? So obviously delta will be equals to 0. So you can call this concept as a collinear. What is meant by collinear? Collinear. So the points which are lie on the same line is called as a collinear. If all the 3 points which are lie on the same line, so then area of triangle will be equals to 0. So in this case, so they have given any 2 points, A and B, and this can be taken at C point as some x, y. To find this equation, what you can apply? Apply the concept of area of triangle equals to 0 since the points lie on a same line. So to find this equation, so already they have given the 2 points. So that third point can be taken as an unknown point, can be taken as x, y. Should be an arbitrary point. Okay. Now for this, delta is 1 by 2 determinant of x1 y1 1, x2 y2 1, x3 y3 1 will be equals to 0, or you can neglect this also, because so 1 by 2 goes to the same to 0, right? So 0 into 2 also 0, right? So same this x1 y1 first point, x2 y2 second point, x3 y3 some unknown point, that is arbitrary point you are taken that as x, y. So by using this concept, you can find that equation of the line joining 2 points using determinants, but only 2 points, right? But for third point, I am taking that as the arbitrary point as x, y. So by using this concept, you can find the equation of line join. Okay. So here, so in this total, we have the total 3 concepts. The first concept, just simply you can find the area of a triangle by using 3 points. The formula is delta equals to 1 by 2 determinant of x1 y1 1, x2 y2 1, x3 y3 1. So this is to find the area of a triangle by using determinants. Okay. So in this, if the answer should be negative, but you can consider that as a positive only, since area should be a positive quantity. If it is positive, you can write positive only. Since while you solving the problem, you will get that answer as a negative, you can write that as a positive, means since area is a positive quantity. Concept number 1. Next, so if they give the one of the unknown point, to find that point, and they given the area, while solving the problem, you can take that area as a both positive as well as a negative, because if it is negative also you can consider, right? But we can write in terms of the positive, but negative value is also there, right? But while considering the problem, you can take a positive, right? So that's why while solving the problem, you take both the positive and negative values, because for this, if you take that 3 also, we will get that positive value. If you take that one more value also, you will get some negative value, right? So for that, we can consider both positive and negative values. Okay. So this is the second concept. And the third concept, so if they are given the 2 points, to find this equation of line, but area of a triangle is about 3 points, right? So the third point can be taken as some of the arbitrary point. So you can take that as a P or C, no problem what it may be. Okay. To find this line join, let's say to find this equation of this line, you can apply that delta equals to 0. So why delta is equal to 0? Since area should be a which quantity? Positive quantity, right? And if it is lie on a same line, it should be collinear. If it is collinear, the area of a triangle will be equals to 0, right? So there is no area you get, so therefore area of triangle will be equals to 0. So now equate this formula to 0. So what about this 1 by 2? See, if we write also no problem, if we didn't write also no problem, because that 2 comes here becomes 0 into 2. 0 into 0 only, right? So that's why it becomes 0. So okay, neglect that also, no problem. Okay, so these are the total 3 concepts they ask in the concept of the area of triangles by using determinants. Got it? So area of a triangle is the main formula. You can write like this also, no problem. If you interchange also, no problem. Okay, don't worry in that one. Okay, main concept is, so formula, so based on that, if that's which question means, you can apply which formula, that's main thing. Okay, so in that, we will do one of the problems. So okay, already know the formula, right? So what is the formula? So area of the triangle, or simply you can write as a delta. Delta is equals to 1 by 2 determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay. So now, so based on this formula, we can solve the first one. So in the first one is find area of a, so find area of the triangle with vertices at the point given in each of the following. Okay, in that first question is 3, 8, minus 4, 2, 5, 1. So how many points they are given? So they are given the 3 points. So what we can find? We can find the area of a triangle. So compulsory they will give by the concept of determinant. Only the question they will ask. Find the area of a triangle with vertices 3, 8, minus 4, 2, 5, 1 by using determinants. Okay. So 3 points later. So mark that points. 3, 8, x1, y1, minus 4, 2, x2, y2, 5, 1, x3, y2. Okay. So you can find area of triangle, right? So write just symbol delta to find area of triangle. The formula is 1 by 2 determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. So just substitute that one. 1 by 2 times of determinant of so what is that? X1 is 3, 8, 1, x1, y1, x2, y2 is minus 4, 2, 1, x3, y3 is 5, 1, 1. Okay. So plus, minus, plus. Already you know how to find the determinant, right? 1 by 2 times of. So for 3, first row, first column, 2 into 1, 2, minus 1 into 1, 1. For second element, minus 8. First row, second column, minus 4 into 1, minus 4, minus 1 into 5 is 5. For third element, plus 1. First row, third column we can do, minus 4 into 1, minus 4, minus 5 to the is 10. Okay, next. So 1 by 2 times of 2 minus 1, 1. 1 into 3 is 3. Minus 4, minus 5. Minus 9. So that minus becomes plus 9 8 72. Next, minus 4 minus 10, minus 14. Minus 14 into 1 is minus 14. 72 plus 3, 75. 75 minus 14 is 61. So 1 by 2 times of 61. So that equals to, what is the answer? It is not exactly divisible, right? We can do no problem. 61 by 2 square units. So that's it. So this is how we can find the area of a triangle by using the concept of determinants. Okay, so they have given 3 points. First point is x1 by 1, second point is x2 by 2, third point is x3 by 3. So this is very important for the 2 marks question. So writing the formula and substitution. So this carries the 1 marks. Okay, x1 by 1, 3, 8, 1, x2 by 2, minus 4, 2, 1, x3 by 3, 5, 1, 1. So normal expanding 1 by 2 for 3, 2 into 1, 2, minus 1 into 1, 1. Next for minus 8, minus 4 into 1, minus 4, minus 1 into 5 is 5. Next for plus 1, minus 4 into 1, minus 4, minus 5 2 is the 10. 2 minus 1, 1, 1 into 3, 3. Minus 4, minus 5, minus 9, minus 9 to minus 8, plus 72. Minus 4, minus 10, minus 40, minus 40 into 1, minus 40. 72 plus 3, 75, 75 minus 14 is 61, 1 by 2 61. So it is not divisible with 2, right? So write as it is 61 by 2 square root. Suppose in case, in this you got negative, it will cancel with no, right? So the answer we can write as a positive only, no problem. In case if you got as a negative. Suppose if it is positive only, you can write positive only. In case you got the negative, you can write as a positive. Okay, so this is how you can solve the area of a triangle by the concept of determinants. So this is very important for the 2 marks. Okay, so in the next class, same we can solve the problems on the same this concept only. Okay, so just learn the formula and substitution and simplification. That's it. Okay, thank you.